Any have a question?
Sorry, I didn't see.
Anyone have a question?
Yes, sir. I want to ask a question, Imad.
Okay.
Okay.
You have shown that random forest and SBM are performing well in comparison with the other techniques that you have simulated. So, what is the reason behind it? Why random forest is performing better?
Sorry, I didn't hear you, or I don't understand the question.
Hello. Should I repeat the question? Imad.
Yes.
My question is why random forest is performing well?
Why algorithms are performing
Why
well?
random forest, mainly why random forest is performing better in comparison to the other algorithms that you have simulated?
Can you please write the question in discussion, then I can respond, because I don't understand.
Okay, you are not understanding my English. Okay.
But my English is very.
Can you tell what are the limitation of your work? What are the limitation of your work?
Yes, limitation is that the best result is 60% of correct answer. I think that the problem come from the data set, because we have only 300 line in data set that we recuperate from a French call center. I think that we need to apply some algorithm and some rules to improve this data set, and searching at a minimum 80% of good of correct answer.
Okay, no question from my side. Anybody else, if you want to ask any question, you can ask.
Anybody else?
Yes, Imad, can you explain your presentation in terms of false positive results? Means, is there any improvement in that kind of thing? Means,
Sorry, he didn't understand.
I just wanted to know whether there is any improvement in terms of false positive. Means you should have you got some less false positive results or like that in your. Okay. Since you are working on chatbot or call bot, so that's why I am asking this question. Okay, no issue. Kamlesh sir, if you want,
Yes,
you can
sir.
ask some more questions.
नहीं ठीक है सर. Okay, Mr. Ahmad.
Okay, Imad, thank you.
Thank you very much, and I'm sorry for my English.
No problem, no issue.
Okay, our next
Next.
paper ID is 214. Mr. Gokul.
Your voice is not clear, Gokul. Your voice is not clear. Unmute your mic and then again it's mute your mic and then again try to speak. It is not audible.
Now it's audible, sir. Is it audible?
Yes, sir.
Yes, now it is fine.
Yes, sir. So a warm greetings to all the session shares. I'm Gokul from Department of CSBS, Tyagaraja College of Engineering, and I'll be presenting my paper titled Flood Severity Assessment using Distilbert and NER. So the table of contents, we'll be looking into the background, literature survey, problem description, methodology, results and discussions, conclusions and references. So background, most of the countries are taking lot of step in disaster management, both for predicting the disaster before it occurs and also for reducing the impact of the disaster after it occurred. So there are like IoT, object sensing, and disaster management. However, machine learning is now is one of the popular topic that is going on worldwide nowadays. So we can also use machine learning for reducing the impact of the disaster. And this paper is one such way of reducing the impact of the flood using some natural language processing techniques. So one of the current procedure in disaster management, that is a remote sensing based method, has a major disadvantages of temporal lags of approximately 48 to 72 hours in providing the information related to the disaster. So this type of lags can also be overcome by ML algorithms. Literature survey. So in 2015, Albert Q and his colleagues have developed a method which used keyword-based approach for disaster management. One of the limitations in keyword-based approach is that it has clear limits in expanding to other it is only focused towards one single disaster or one single language. So this kind of problem arises in this paper. And in 2016, Chang and his colleagues developed a real-time local event detection in geotag tweet streams. So this paper actually used the geotag tweets for detecting the disaster-related events. Geotag is a feature that a user has to turn on when he creates his account, but major users does not turn on their geotag. So this is the drawback of this paper. And REST in 2018, REST and his colleagues proposed a method using latent derelict allocation for disaster tree classification and hotspot analysis for spatial analysis. So latent derelict allocation has a major drawback that the number of topics that has to be computed by LDA has to be fixed in the first. So in successive iterations, we cannot change the number of topics. And also there is an issue with hotspot analysis is that if there is a single outlier in one particular area, then it will produce a local hotspot in that particular area, and the rest all areas will be ignored completely. In 2019, Kant and his colleagues have developed a Twitter-based disaster response system for Indian scenarios. This paper just classified the tweets into donation and rescue using some basic machine learning algorithms. It does not take any other features into account. And in 2022, Kant and his colleagues developed deep learning based assessment of flood severity using social media streams. Actually, they collected the tweets and images from the Twitter, and they classified it using BERT and CNN. BERT has a major disadvantage of BERT has a major disadvantage that it is very slow during real-time events. While collecting the tweets from the Twitter in real time, that is active tweets, the BERT's performance will be slower, and that is proved by many case studies. And we have cited everything in the paper. So they use geotag, and also they used geotag tweets, which is also a disadvantage, and they also didn't take the temporal factors for consideration. Problem description. So as everyone know that floods have an adverse impact on people's life and property. So we have to definitely, the severity of floods need to be monitored to reduce its impact. And our paper uses Twitter as the source of information, which can be used for reducing the impact of the flood. So what we'll be doing is we'll be collecting the tweets and we'll be analyzing it, and we'll be helping the people who are in need for help during severe floods. And it is critical to use the advancements in deep learning and NLP for spatio-temporal analysis of flood severity assessment from the tweets in Twitter. So this is our overall methodology. First, for training purpose, we have taken the data set from the Twitter during Chennai floods 2021. That is from November to December, 2 months data we have taken from the Twitter, and we have pre-processed and tokenized using Distilbert preprocessor and tokenization packages, which will do all the required pre-processing steps like removal of emojis and removal of hyperlinks, etc. And we are fine-tuning the trained Distilbert model. So Distilbert model is a distilled form of BERT, which is smaller, faster, and lighter transformer model based on BERT architecture. BERT represents bidirectional encoder representation from transformers. It is basically a transformer encoder stack that generates contextualized embeddings. And BERT generates the embeddings for each sentence, and it produces some meaningful number representation for given word. And it also has a larger feed-forward neural networks of 768 hidden units and 12 attention hits. BERT was trained with 2,500 million words from Wikipedia and 800 million words from different books. And it was also trained using masked language model and next sentence prediction. So Distilbert has 40% fewer parameters than BERT and 60% faster than BERT. So we are fine-tuning the Distilbert model with tokenized text from the pre-processing step, and a dropout layer was also included to reduce the overfitting of the model. And the model is trained with the Adam optimizer along with binary cross entropy loss function. And we trained our model for 100 epochs, and all the metrics like binary accuracy, precision, recall, and everything was found out, and it was in the results and discussion section. So after fine-tuning the model will classify the tweets into flood related or not. If the tweet is related to flood, then we are going for the next step. That is, we will be implementing NER. NER refers to named entity recognition. Named entity recognition is a natural language processing algorithm in which the named entities are predefined categories chosen according to the use case, such as name of the people, organization, places, or etc. So we'll be finding the location that is mentioned in the tweet using this particular NLP algorithm. And then we'll be we'll be doing spatio-temporal analysis based severity assessment. So once we have completed this methodology, we can identify the exact location and the exact time of the high severe exact time when the severity of flood is very high, and we can assist the government and the volunteers and some NGOs to provide help to the people in that particular area to reduce the impact of the flood. So these were the results and discussion. So text classification, first let's see about text classification. The performance of Distilbert model is compared with the other models such as support vector machine, artificial neural network, convolutional neural network, bidirectional long short-term memory, and BERT. And from this table, it can be inferred that Distilbert has the highest accuracy of 99% for text classification. And the reason for why the Distilbert has such a good accuracy is that Distilbert and BERT are exclusively natural language processing models, and it is especially designed for such kind of activities when compared to other machine learning and deep learning models. And the reason for why Distilbert outperforms BERT is that Distilbert has only 50% of the BERT's layers, and also it does not contain the pooler type and token type embeddings which is present in BERT's architecture. So these two characters will automatically improve the performance of the BERT. So these are the reasons for getting the highest accuracy of 99% for text classification. Spatio-temporal analysis. So most frequently occurring locations are obtained using NER. The main advantage of using NER is that it does not require geotag to identify the location. So from the graph, location frequency graph, it is evident that the impact of flood is more severe in places like Nunganbagam and Embassy Nagar when compared to the places like Anna Nagar and VR Mall. And a time graph is also computed to know the exact time. Actually, here we are plotted the date graph, but we can extend it to time to know the exact time of the high severity of the disaster. So it can be inferred that most of the rain and flood related tweets were posted on 31st December 2021, which is exactly true, as on 31st December 2021, we had a huge rainfall in Chennai. So discussions. So Distilbert has certain disadvantages, certain advantages over the other existing methods, since the classification of text is done using non-keyword based approach, and named entity recognition primarily uses location specified in the text to overcome the major disadvantage faced by the geotag based approach. And so there are some limitations are also there for the proposed methodology. The active Twitter users may be less due to the network problems, which might be a challenging situation for applying the proposed methodology. But there are a lot of case studies that this kind of methodology is very useful in reducing the impact and knowing the exact situation of the areas, and how the flood have been affected, how the areas have been affected by the disaster. Also, it is hard to guarantee that a tweet or retweet describes the real damage status that a person experienced during flood. Conclusions. So the performance of Distilbert is compared with other baseline models like all the BERT, LSTM, CNN, etc. So as a result, we conclude that Distilbert is the best model for text classification, and it is very faster compared to other models. And after classifying, the flood-related tweets are utilized for the identification of location and time of the severity of disaster with the help of NER and temporal analysis. So in future, definitely we'll be the location identification method can also be improved with better semantic analysis. Further, different kinds of data other than text, such as images, videos, etc., can be used for flood severity assessment. So these were the conclusions we have referred to, and thank you. That's it from my part.
Mr. Gokul,
Yes.
आवाज आ रही है? आप जो कंपैरिजन टेबल है एक्यूरेसी की, वो आप निकाल के ना, एक्यूरेसी टेबल जो है आपके प्रेजेंटेशन में,
accuracy.
Can you go back to your result?
No, previous. Okay. Mr. Gokul, which type of machine learning method apply for improving the accuracy in Distilbert method?
Yes, sir.
Which type of machine learning technique apply in the Distilbert method, Distilbert technique to improve the accuracy approximate 99%?
Yes, sir. We have applied this and we have found out the accuracy. We have set for 100 epochs and we got this accuracy.
Which type of method, which type of machine learning technique apply?
That is machine learning type, which type in the sense natural language processing, sir.
Type of algorithm?
Type of algorithm. Actually, it is a transformer based algorithm, sir.
Transformers based.
Why you did not note your F1 score, sensitivity, specificity, ROC, AOC, all these things? Why you are not noted?
We'll include, ma'am. We'll include, definitely.
इसमें आप Mr. Gokul, please include the technique for the machine learning for each method.
Yes.
Okay. Basically, the result of the accuracy, precision, and recall change from each and every technology, SBM, ANN, CNN. So please set up the parameter to change the accuracy, precision, and recall. Okay.
Yes.
Okay. Anyone else have a question, please?
Gokul,
Yes, sir.
actually you have developed this work for flood
Yes.
affected area. Okay.
If
Okay, in case of flood, there is problem in communication also. Then
uh,
how will you collect the data and how will you this work?
we can collect the data from the Twitter, sir. Actually,
How
during
that Twitter will work in case of flood? Means there will be many towers which will be not working in that particular area.
that's what we have mentioned in the limitations. We have certain limitations, and we are working to improve it, sir. Actually, so
Okay. Okay.
Okay, Mr. Gokul.
uh, thank you, sir.
Okay, our last paper ID is 159.
So can I share my screen?
Yes.
Thank you, sir. Is it visible?
Yes.
So can I start the presentation? Yes. I am
Okay,
Saurabh
Mr.
Agrawal.
Saurabh.
Yes, sir. Thank you, sir. I am Saurabh Agrawal, PhD scholar from the National Institute of Technology, Raipur, in the Department of Computer Science and Engineering, under the supervision of Dr. Dilip Singh Sisodia, sir, and Dr. Naresh Kumar Nagwani, sir. So, paper's title is Function Characterization of Unknown Protein Sequences using one-hot encoding and convolution neural network-based model. This is the table of content, background, literature, survey, problem description, methodology, results, discussion, conclusion, and references. So, protein subcellular localization prediction is utilized for the protein subcellular localization prediction of recently evolved unknown protein sequences vital for understanding the protein functions. While protein functions are harmful as well as useful for the human being and other living organisms. So function characterization is used for the disease
Like I
diagnosis.
was trying to, I mean, oh shit.
So function characterization of or function prediction of a protein sequence provides insight into the predict the harmful and useful effects of the protein sequences, especially newly evolved protein sequences, disease diagnosis, drug design. In this work, one hot encoding is clubbed with the convolution neural network, and one hot encoding based neural network model is proposed for the function characterization of protein sequences through the protein subcellular localization. Protein subcellular localization is the localization of cell which is available in the each and every category of the protein. So this is the literature survey. Function characterization of recently evolved protein sequence is crucial to understand the various molecular and cellular process mutations of bacteria and viruses and drug repositioning and drug designing also. So exponential number of new protein sequences are evolved with the advancements in proteomics and genomics projects, mutation of natural bacterial mutation of bacterial proteins.
Saurabh, you
Oh,
can skip this slide.
okay.
Just go ahead. Go ahead. Next.
So main motivation of this work is to for the function characterization of unknown protein sequences using computational approach. There are wet lab experiments or biological experiments are available, but it is time taking for the large number of protein sequences. Therefore, in this work, we have concentrated on the transformation of protein sequence residues into the compatible format. Generally, protein sequences are the combination of 20 alphabets with variable length. Therefore, in first objective of this work is transformation of variable length protein sequences into the compatible feature format using one hot encoding. Then second one is standardization and normalization of the variable length protein sequences. After that, this normalized protein sequences is used with the convolution neural network with the optimum combination of the activation and optimization function. This is the methodology of the work. In this work, we are taking gram-positive data set with 4 subcellular localizations. So there are total 473 plus 50. So there are 523 protein sequences are available in benchmark gram-positive data set. And this 523 sequences are distributed in 4 localizations. So therefore 4 localizations are the classes. So in that data set, we have distributed the 433 as known and 50 as unknown. For the unknown protein sequences, we are not using the protein subcellular localization or classes. So in the first step, 473 gram-positive protein sequences are used for the training of the model. In first step, pre-processing is applied. Protein sequences, just like here is given as MBID, is encoded using one hot encoding. Because there are 20 residues, therefore 20-bit in one hot encoding is required. If the length of protein sequence is 10, then encoded sequence length is 200. Because the variable protein sequence length of the protein sequence is variable, therefore in the next step length of that sequence is fixed through the padding and capping. So we have fixed the length according to the available data set. For this data set, we have fixed the length to the 400 residues, and in different data set length will be varied. It is totally based on the data set. So in the standardization and normalization step, capping and padding is required, is applied. If length is less than 30, then we can pad that sequence with some zeros to make it 400. If length is more than 400, then we can cap it or cut it. In the next layer, in the next step, standardized encoded and normalized sequences are used for the function prediction using different combination of activation and optimization function. So in this work, six combinations are used: ReLU softmax Adam, ReLU softmax SGD, 10H softmax Adam, 10H softmax SGD, sigmoid softmax Adam, sigmoid softmax SGD. So for each protein sequence, for non-protein sequence, this model, OCNN model, is trained, and this is the result. So we can get the best result with the combination of sigmoid softmax and Adam. Accuracy of model is 92.94% with the with the known protein sequence dataset. After validation of this model with the known protein sequence, we are using 50 unknown protein sequence. In that 50 unknown protein sequences, classes are or protein subcellular localizations are not utilized. This is used for the verification of the model. So this is the outcome of the model with the unknown protein sequence. In this model, performance of the ReLU softmax and Adam is highest in comparison to the other combination. So this is the conclusion. Function characterization of a protein sequence is crucial for the different biological applications, such as study of cellular and molecular processes, bacteria and virus mutation, treatment plan, and repositioning of drugs. In the present study, PSL-based computation framework is proposed to identify the function of unknown protein sequences using one-hot encoding and convolutional neural network. Gram-positive bacterial benchmark dataset with known and unknown samples have been used for the experimentation. OCNN model achieves 92.94 accuracy through the combination of sigmoid softmax and Adam functions with known gram-positive protein sequence samples. Further, validated model is utilized for the protein subcellular prediction of the known protein sequences. while function of protein sequences relies on the localization of the cell in which it resides. When OCNN model attains 64.83% accuracy with the independent protein sequence samples of UPS dataset through the combination of ReLU softmax and ADAM function. These are the references for this work. Thank you.
Okay, Saurabh.
Yes.
What I observed, you have taken only a single data set having 473 tuples
Yes.
for doing your simulation. So you should try with more number of data sets. You cannot conclude that this or your CNN is performing better by doing simulation
Yes,
only
ma'am.
with a single data set, right?
Okay.
Then my second question is, what you are doing, you are using one-hot coding to convert the protein sequences into the combination of 1 and 0, right?
Yes, ma'am. Yes, ma'am.
Then can you explain more what, how you are doing the normalization in such type of 1 and 0 combination?
We have allotted every residues. For example, if there are 4 residues A, B, C, D, so we have allotted A as 1, 0, 0, 0, B as 0, 1, 0, 0, C as 0, 0, 1, 0, and D as 0, 0, 0, 1. So if in the combination there is A, B, C, D, then that encoded sequences are incorporated.
No. My question is how you are doing normalization. You told now you did normalization.
There is for the normalization we have fixed the length according to the average length of the protein sequences in whole data set. If there are 500 sequences in the data set, then we can take the average of the length. After that, according to the average length, we can define the length of the sequence. According that, we are applying the capping and padding in the sequence for the normalization.
Whether your data is balanced or unbalanced.
This data is in gram positive data set. Generally, data set is balanced, but some other bacterial protein data sets, just like gram negative or virus and some other protein sequence, both types of data sets are available. So in this work, we are using the balanced data set, but in other works, we are also using the imbalanced data sets.
So you try to add the result of sensitivity, specificity, more particularly area under curve, and
Okay.
try to represent your RSC curve. That is
Yes.
more important in comparison to your accuracy or response. That's from my side.
Yes.
Other chairs can ask questions.
Anyone else have a question? Okay, Mr. Saurabh. Good.
Thank you, sir. Thanks to session chairs and MISP organization committee for giving me pleasure to present my paper in this platform. Thank you.
Thank you, sir. Thank you so much. On behalf of the NIT Raipur and organization committee of the conference, I thank you all for the sparing valuable time as well as providing valuable insight to the authors. It is kindly requested to the session chairs to fill the evaluation sheet so that the page paper can be awarded and decided and finalized. May I request to the session chairs and participants to turn on their camera, please, so that we can take a group photo or a snapshot.
Bilkul, sir.
Sanjay sir.
थैंक यू सर कमलेश
Okay,
सर
thank you, sir. कैसे हैं सर आप?
मैं बहुत बढ़िया हूं सर थैंक यू
Sir,
फॉर
बहुत दिन
स्पेयरिंग
से-
योर वैल्यूएबल टाइम
बिल्कुल, sir.
बबीता मैम थैंक यू वेरी मच संजय सर वेरी संजय सर डॉक्टर नजमून नासा मून फ्रॉम बांग्लादेश Thank you. Thank you, Dr. Moon, for joining us. Thank you to all participants also. Yeah. Sanjay sir.
सौरभ सर ऑन करो ना कैमरा.
Yeah. Okay. So at 5 p.m. Validatory session of this conference is scheduled. So you all are requested to join, please, at 5 p.m. today. Dr. Director NIT Raipur and Director Triple IT Naya Raipur, Professor P.K. Sinha will grace the occasion. So I would like to request all session chairs as well as presenters, please join validatory session also. Thank you.
Thank you, sir. Thank you.
Thank you, sir. Thank you.
Thank you, sir, ma'am, and other participants. Thank you very much. Thank you so much. Thank you so much for joining.